So in this question we have two inputs, k means k numbers, and n means the sum, the result. Only 1 through 9 into these numbers, and each number is used at most once, which means we only have which means we have to use k numbers and plus these k numbers together to reach n, and we can only choose the number from 1 to 9, and we can use them only one time or not use it, and the return is a list of all possible valid combinations. So in this example, k is 3, n is 7, which means we have to use 3 numbers, add them together to reach 7, and these 3 numbers are not the same. So let's my algorithm is backtracking. I think k is from 2 to 9 and n is from 1 to 60. So in my thoughts, we can use a DFS. After we choose the first number, we can calculate the remaining n. Like in this example, k is 3, n is 7. Firstly, we choose 1 as the first number. We can choose from the smallest end to the biggest end, which means from 1 to 9. And firstly, I choose 1 as the first number, so the remaining k will be 3 minus 1 is 2. The remaining n is 7 minus 1 is 6. And the next number I can only pick up from 2 to 9 because each number is used at most once. Say 2 is the second number, and the remaining k is 2 minus 1 is 1, and the remaining n is 6 minus 2 is 4. When the remaining k reach 1, when the remaining k is 1, means we have to put all the remaining n into next number. So the next number will be the remaining n is 4, and 4 is not in use because we can choose a number from 3 to 9, and finally 1 to 4 is a valid combinations. And let's do the backtracking. to the second number choosing. This time we choose 3, and the remaining n will be still 3, but the third number we have to choose it from 4 to 9, because we choose each number in the ascending order. So if we choose the ith number as j, we can only choose I plus 1's number from j plus 1 to 9, because we pick up the number in ascending order. That makes sense. So in this case, n the last number can only choose 3, because the remaining n is 3. It's less than the window of the choosing number, so this will be an invalid combination. And let's do another backtracking. We choose the first number as 2. The second number must be 3. 2 plus 3 is 5, and the remaining n is 2. 2 is not in is not in the range from 4 to 9, so it's invalid. I think that makes sense. We use backtracking. The backtracking will use DFS, and the input and the result of this function looks like DFS. Is fit for the recursion function. Yeah, we can use recursion function. Let's say we want to return the we have to define the return case, the invalid case. If right now the k is 1, we have to choose the last number as n. Let me see. We also have to remember the window, the range of the valid number. So we need another parameter. We can let left is 1 because we can choose from 1 to 9, right? And we use ascending order, so we choose left as 1, not 9, and after each go into and backtracking, we can change the value of this left. And I think we need to save our answer into an array, which is empty right now. And we have to remember the path. So the function can know what's the status right now. So path is an array of number, and the answer is a matrix, which means the array of the array. And let's get started from the first input. We can define a recursion function. Let me think about this. Can we only use a while loop? Or a for loop? And we choose a number, put it back, and put this to the path, and calculate the length of the path No, we should use a recursive function because this is easy and we want to make a lot of errors. Let's try to add a function which have k is the remaining k, right? And n is the remaining n. And the left is the window. Do we also need a right? Maybe we can have a right, because every valid combination is ascending order. If the k is 3, the right would not be 9 but 7. Seven, 8, 9. So the first number can only choose from 1 to 7. Yeah, this is truly weird. But if the remaining k is 1, then we have to add the remaining n to the path. Let's check if the remaining is bigger or equal to left. Remaining n is smaller or equal to right. Then we can add this into the path. Push the remaining n, and add the answer dot push is path. After that pass, we don't need to clear the path because path will maintenance in every go into and backtracking. After that we return, right? And because we use path, we don't need to return an array. We can return void. How to spell this? I don't know. You don't need that. And if the remaining k is not y, right, we have to choose a number and push it into path and go into a deeper level, the next level. So right now we need to firstly check if the remaining n is smaller than the left. We have to do the return. And this would be invalid one, right? So right now it's bigger than left. We can add it to the path. Path dot push. The let's say from left to the right, so we need a for let I is left, I smaller than, smaller or equal to, it's really weird. I double plus, and in this loop we push I to the path. So path dot push I, and we do the DFS remaining k minus 1 remaining n minus I, as we agreed, and left is I plus 1, and the right is right plus 1. Yes. After that we use path.pop to maintain the status. So after all the recursion, we can get the answer. So firstly we should call DFS from the k n 1 and 9 minus k plus 1, right? For example, k is 3, 9 minus k plus 1 is 7. Yeah, it works. After that we return the answer. So before we started running, we have to do the dry run. Let's pick the firstly let's pick this example, like k is 4 and this 1, left is 1, and from this k and 4 1 1, 9 minus k 4 5 plus 1 is 6, 4 1 1 is 6. Okay, so 4 4 1 1 6, and into the DFS. Remaining k is not 1, so it goes here. The remaining n 1 is less than left 1. It's not, right? So we goes into the I equals to left I double plus. So path we push I into this, and which we goes into 3 and 0. We have a problem here. It goes 0, and I plus 1, I is 1, right? Two right plus 1 is 6 plus 1 is 7, and dive into the second level, it will goes here. The remaining n 0 smaller than left 2. It failed. So I think we can do something to avoid this happen. We can, let's say we can change this part. We can change the window, the size of the window, because we might not reach the one of the end in this window. For as this example, because n is equal to 1, we cannot reach the level of 6. So I think we can calculate the right end like this. We choose the smaller one, right? We choose the smaller one. We can use math.main. We choose from this number and n. This would be work because n is 1, right? So there will be 1, and left and right would be 1, 1. And we can also change the this left and right, because right now we can only reach from I to I, and this remaining k, this is remaining n. So I plus 1 remaining n is 0, but I plus 1 is 2. We can firstly we can add a math main from here. We choose the main number from right plus 1 and this one. And we can use I plus 1 here, but we need to add another if in the top of it. Yeah, push it here. It equals to the left. Or left is smaller but is bigger than right. These are also invalid, right? This is also invalid. So it goes into here, I plus 1, this goes 0, and the remaining n is 3. It's smaller than left. And let's choose another valid example. Say example 1. It might works. K is 3, N is 7, and 1, and this would be 7. This also is 7, is 7, and the remaining n is bigger than left, and the left is smaller than right. The remaining k is not 1. So going to here, left and right would be 1, 7. And push 1, right? And it goes to 2, 6. I plus 1 is 2. Choose the minimum list. This one is 8, and this one is 6. So 6. No, it goes here. Choose the I from 2 to 6, and let's choose 2, right? So k is 1, and the remaining would be 4, and I plus 1 is and I plus 1, I is 2 plus 1 is 3, and the minimum is 4, I think, and it dives in here. And the remaining n is like this: 4, 15, 3, and 4. So we add it and push the path right now here, and we also need to path.pop, right? Goes back to the second level, which we choose not 2 but 3. So the remaining would be 3, and this one would be right plus 1 is 7, and this is 3. So choose the last one. Choose the last one is 3, and left is right, and the remaining n is smaller than left. Oh, my fault. So I choose I is 3 here, so it goes 4. 5 still is 3. 6 minus 3 is 3, so this two number is right, this one is wrong, and because here it's invalid and it goes backtracking, right? After that we choose 3, 4, 5, 6. When we choose 3, the remaining I would be 3. So this would be work. We not return from here, but return from here. I think that's right. Let's check. It's right. Oh, wrong answer. Oh. Oh, we shouldn't push path. We should push another copy of path. So we can use like that. Yeah, everything accepted. I think this would be good. Yes, perfect. Oh, I forgot to analyze the complexity. So the time complexity, because we maybe choose 9 times, because I from k from 2 to 9, k from 2 to 9, yes, and I from 1 to 9, and also the time complexity will be 9 order of 9. Not 9, I'm sorry, I mean 9 order of k. Yeah, big O 9 order of k. And a fewer version I think is n minus k order of k. So the time complexity would be O k n minus k order of k. Because every time the size of the window would be less or equal to n minus k, it won't be greater than n minus k. So every time we choose, we have only these choices, and we have k time. So this is time complexity. And for the space complexity, we have big O, so we only use this to remember the status and remember the final answer. And we use DFS, so it will also cost a lot in the recursion. So this takes us how many? So k times k times n, k times n square, and this costs us so the space complexity would be k times n square I don't know if the function count in this space complexity.